Welcome to Academic Daddy class. Subscribe. Today I want to teach you projectile motion. And I'm not going to rush into like trying to solve questions and the rest. I just want to teach you first of all the principles of projectile motion so that you can be able to know how to tackle the question. So I classify it under cases. So the first step of projectile motion you will see, case 1, is when I have a horizontal, that is the flat surface, the earth surface. All of us will make use of it. And they tell me that a body is projected at an angle theta. That means the projection makes an angle with the horizontal. That is the plane of projection. So they now tell me that it now comes down. This is the first case. Forget the drawing, understand what I'm trying to teach you. Then case 2 is when they tell me that a body, this is the height, ground level. Then they come and tell me that a body is projected at height above the ground at an angle. So at an angle, then before coming down. So all this drawing I'm drawing, I don't know. This thing is so let's do it again. So I believe you understand. I'm using free hands. So at an angle, this is the angle. Let's say this is theta. So all I will do is to still remember at the point of projection, I'll come and put dot. I'll come and make it to become straight so that I understand. So it starts here, then ends here. Then case 3 is when a body is projected at height above the ground. Body is projected at height above the ground, but this time around it's projected horizontal before falling. And you know that if you project, let's say a ball here, let's say you put a ball here and you kick it horizontally, or let's say a man is flying on an helicopter and he drops a bomb. If he throws that bomb with his hand horizontally, as he moves, at a point it will move and then make a curve. So that's case 3. When the body is projected at height above the ground, then horizontal, this height will always be given. Because if it's not given, then means you should consider it as case 1. So the height is always given. That is case 3. Case 2. Now in case 4 is when they tell you that a body, this is the plane of horizontal. They tell you a body is thrown up vertically. That a body is thrown up vertically. And if it goes up, let's say a ball is thrown up vertically, you throw a ball up, it will come down now. This is case 4. Case 5. They tell you a body is projected horizontally. Like you play a ball to your friend and he traps it. That ball is projected horizontally. So you see, he has no business vertical. Then case 6, and that should be the last case. We have different cases, but this is the tangible cases, and all other cases falls under this. So let's say I have a body. This is the plane of horizontal. Let's say I have this to be vertical axis, horizontal axis. Vertical axis, horizontal axis. Then a ball is played. You play your ball, you go up at an angle, you're enjoying yourself, at an angle. Then instead of the ball to land to your friend, you've played too much, it will come and land on top of zinc, on top of a building, and stay there on top of the roof. So this is case 3. You play it, you go up, you come and land somewhere. Case 6, sorry. So all these cases that we've brought up, let's now check something. We know that, first of all, let me just keep this one side. Now we know that projectile motion, we say that projectile motion, is the motion of a body through a curved path. That is the motion a body makes through a curved path, and this path that it traces is what we call trajectory. Trajectory path. So the motion of a body through a curved path. Now notice something. If I have this body to be vertical axis and I have this side to be horizontal axis, notice that in kinematics, that time you did kinematics, you will come and do this side, you come and say let this side be v, let this side be t, whatever is moving here is acceleration. If it goes like this, constant acceleration. If you go like this, deceleration, v and t. But in this case of what's it called, projectile motion, your focus is strictly on the y-axis, vertical axis, and the x-axis, while whatever is happening here, that is projection, the projection goes with a velocity. So let's treat the first case, which is case 1, where the body moves at an angle theta, and it now comes down. Notice that as it's projected, at this point it has a velocity. For the fact that something is projected, that it has been thrown, it is that type of motion that goes with just one initial velocity. For the fact that it's projected, at a point it must come down, and when it comes down, it becomes the final velocity. So let's say at this point that is projected, it will have this velocity, which is the initial velocity at this point. It will also have it at this point, and you know that this side is y, this side is x. Now let's say when this velocity gets to this point, notice that at this point is no longer the initial velocity it's projected with. At each point it will be changing, the velocity will be changing, but the components will always remain in such a way that it will be checking for the y and the x axis. So at this point I will have it in such a way that anything I do, whatever I do, my velocity will be in between. So let's check how to make this to fall in between the x axis and the y axis. So you see that at this point, if this is projected, at this point where you have maximum height, you see that I can choose to consider this as my y and consider this as also my x. But notice something, if I consider this as y, consider this as x, it's almost as if it's no longer x. But that's just to tell you that at maximum height, there's nothing velocity, the horizontal velocity is looking for there. So that is why you take it that when you are considering this at maximum height, notice it, you've reached the highest point, so the v is changing, it will be 0 at this point. The v is 0 at this point, because if you throw it up to get to a point to stop moving, then it will start coming down. Then notice that at this point, let's say the velocity now move this way. At this point, notice that you have also your plane, in this direction, that is y side, x side. So notice that for each part of this projection, as it's moving, it is tracing right angles all around. So this is the velocity. So here is v, it's changing v, but here it remains u. So once this body is thrown, you need to just understand the part where you get to see that initial velocity is just once. Every other thing at this point is changing, becoming so many things. So if they ask you what is the velocity at which so this one happens, so this one happens, just pay attention well. So now let's see. You remember that if I have, okay, that this is x-axis, this is y-axis, and this is the velocity, no problem. Notice that if this is the case, when I have this to be the velocity, notice that vector law says that what I have here is also this side. So I can come and put it here. So this becomes my resultant. This becomes Vy. This becomes Vx. So I can now use the laws which says so ka toi. So if I use so ka toi, I will now say sine theta is equals to opposite over hypotenuse. And right here, this is opposite, this is hypotenuse. Or let me use u instead of r because we are dealing with velocity. So Vy over u. So which means that Vy should be equals to this. We'll go and meet this u sine theta. So once I'm doing projectile motion, anywhere I see Vy, that is where I should put initial velocity. Where I should put initial velocity or velocity at all, I'll just call it u sine theta. Then for cos theta, I remember that it's adjacent over hypotenuse. Here is the adjacent, this is the hypotenuse, the longest side. So I have Vx over u. Cross equality sign, cross multiply, you get Vx times 1, then equals to u cos theta, equals to u cos theta, equals to u cos theta. So now for the tan theta is always opposite over hypotenuse. Opposite opposite over adjacent. What are you saying? Toi, opposite over adjacent. Opposite over adjacent. That is Vy over Vx. I know that Vy is u sine theta and Vx is u cos theta. You see that this will cancel this. So you now have sine theta over cos theta. So now that I know this, we will use the idea of anywhere we see anything that has to do with vertical axis, we'll put u sine theta for it. Anywhere we see something that has to do with x-axis, we'll put cos theta for it. And you need to remember that if I throw a ball up, it's going against gravity. So for that reason, the g will be equals to minus g if I throw a ball up. But if a ball is coming down, you hear something is coming down, you need to know that as it's coming down, g will be equals to plus g. G will be obeying gravity, so it will be plus g. And you need to know that when something is thrown up, the final velocity is 0. And when something is thrown down, you take it that when it lands, it can move in different direction. But before it is thrown down, it has initial velocity to be at rest. U is equals to 0. You need to know this. Then, if I hear that something is thrown up, it simply means that if they ask me calculate the displacement of something that went up and came down, it means that when it went up, it is going in positive displacement, and as it came down, it's going in negative displacement. So for that reason, plus and minus will equals to 0. The s here, the total displacement, will be equals to 0. You need to know that. Then if I also hear something is thrown up, it means that whatever velocity I'm giving there is for the y-axis. The u will be whatever I'm giving. Let's say I'm giving 50, it will be 50. That is for velocity on the y-axis. While on the x-axis, velocity will be 0. And if I hear that something is thrown vertically or projected vertically, that means that projected horizontally, that means that uy will be 0. There will be no initial velocity there. But ux will be whatever velocity I'm giving, let's say 50. So now that I know this, uh, let's now try to go back and look at our equation of motion. If you remember very well, equation of motion gave us v equals to u plus at. It also gave us v equals to v square equals to u square plus 2as. And it also gave us s equals to ut plus half at square. This is what it gave us. Now, I want you to know that anytime you want to find time of flight, it's a time to reach maximum height, you use this one. Time to reach maximum height. You will see what I mean. Use this one. And anytime you want to calculate maximum height, you use this one. And anytime you want to calculate total time of flight, total time of flight, and anything that has to do with projectile outside case 1, that is from case 2 to case 6, you use this one to derive everything you're deriving. Now let's see what I mean. I will quickly remember that we've already gotten that anywhere we see u, let's say this time around I will group this, I will do this in such a way that I will focus on, I've noticed that projectile motion is motion that has to do with vertical and horizontal axis, and it is in such a way that when I'm talking about vertical, I don't need to talk about horizontal, and when I'm talking about horizontal, I don't need to talk about vertical. Let's still do something here. Notice that g, when a body is projected up and down, that's when we talk about g, that is gravity. But if a body is projected horizontally, it has no g, it has no gravity, so gravity is 0. So the only thing that acts on horizontal axis is friction and not gravity. So I normally tell my students, friction is to the horizontal what gravity is to the vertical. So once I know this, let's now use all these equations of motion that we have here. So on the vertical axis, you will see that when the body is going up, v will be equals to 0. Equals to, as it's going up, any velocity given there, for the first one, that's what we are checking, will be present for it. Then as it's going up, it's going against gravity, it will become minus, and the a there will become acceleration due to gravity. It will be replaced by g, then t. So this will now be u minus gt. That is, we got it from this one, the first one. Remember, we brought it out so that we used to check something. So now, if I make, trying to make g subject of the formula, t subject of the formula, this will cross, it will become minus g equals to minus gt. This and this will cancel, so that I now have u equals to gt. Divide both sides by g, so that you now have t is equals to u over g. T is equals to u over g. But remember that from our discovery, we said once you are dealing with the vertical axis, no longer call uy. This v I used, I could have as well used u. So no longer call it uy. That is initial. Rather call it u sine theta. So where I see this, I will replace it with, where I see u, I replace it with u sine theta all over g. And this is what we call the time to reach maximum height. Now let's go to equation 2. That is equation 2 of kinematics motion. This is v square equals to u square plus 2as. Now I'll say v square equals to u square plus 2as. Let me write everything. Now we are trying to get maximum height, And at maximum height, v will be 0. If something is thrown up, v is 0. 0 square equals to whatever I'm giving for u, there will be there, u square. Then since it's going up, maximum height, that is what we are trying to find, the g will be, this is going to be g, so it will carry minus g, and if it will affect this, so this will be minus 2gs. And the s here is talking about height. Whenever you're talking height, the s for displacement changes to a h, because even displacement gives you the distance, and anything of that such at vertical axis is no longer considered a length, or in distance rather the height. So if this cross equals to, I have minus u square equals to minus 2gh. So notice that if I try to make this and this can cancel out, so that I have u square equals to 2gh, making h subject of the formula. I have 2g over 2g. This can cancel this, so h is equals to u square over 2g. Now notice, anytime you are given a question to find maximum height and it doesn't have an angle, that question does not have an angle. If it doesn't have an angle, no angle given, this is the formula you use to find your maximum height. But once an angle is given, you'll remember that h is equals to, that the u there is equals to, notice something, the u there is equals to u sine theta, this u sine theta. So you quickly rush and change the u there to u sine theta, and it's all square over 2g. Now notice that, remember that h is equals to, this square, distributive power law, will be u square sine theta square, but we normally write it as sine square theta all over 2g, and this is your maximum height. So this is formula for maximum height. And notice that everything, all the equations I'm giving you is for case 1, just case 1, when it's from launched from at an angle from the projectile, that is from the horizontal. Now notice, if a question is given to you and that question does not have any angle given, they tell you to find the time to reach maximum height, but the question given to you did not include any angle, this is the equation to use when no angle, or when no theta or theta, no angle or theta is given. This is the equation to use. But once there is an angle given in that question, you remember that u means u sine theta on the vertical axis. Now for the horizontal axis, let's just try and derive the things we've derived for this one. If I am at the horizontal axis, applying this v, v equals to u minus gt. So what it means is that at horizontal axis, at the horizontal axis here, see, at the horizontal axis here, if they ask me to find the time to get this horizontal axis, the time I will be considering will no longer be time of maximum height, because maximum height is simply to go this way. So it simply means that this formula to find, even let's see it, so that you see that you cannot find time to reach maximum height on the horizontal axis, because see, this will be v equals to, and as v is coming down, like as it's coming down, when the body is coming down to meet the, that is, it moved like this and is coming down, as it's coming down, its u will be 0, its initial velocity is 0. Remember I taught you this, that when something is coming down, when something is coming down, its u is 0, so its u is going to be 0. And notice that there is no g on the horizontal axis, g is 0, so this is now u minus 0 minus 0t, which is the same thing as 0, v equals to 0. So there is nothing like time to reach maximum heights. There's nothing like time to reach max height on the horizontal axis. No time to reach maximum height on horizontal axis. So that is the first thing. Now let's check if it's possible to get maximum height on the horizontal axis. Now v square is equals to u square plus 2as. So if the body, if this is our projectile and this is horizontal that we know, notice that at this horizontal point, when the body moves like this to like this, v square will simply be equals to, as he move up coming down, u will also be 0. Then this will now be minus 2, it has no g, minus 2g h, it has no g, which is 0, and even it has no height, 0, 0, 0. So you see that there is no such thing as v square equals to anything or maximum height, so this is not obtainable in the horizontal axis. So for that reason, we move to what we call range for the horizontal axis, and we know that range talks about if I have this to be the projectile and I have this, range talks about the distance from this end to this end. So if I know this, and there's only one initial velocity, so range talks about the initial velocity with which it is launched and the time it took from this point to get to this point. That is the total time of flight. So it's going to be simply r is equals to, or I can derive it from s equals to ut plus half at square. And I know that s here is going to mean range. This displacement is equals to the u and the t, then plus half the g here, even if it happens to be plus, let's say put plus g, then put t square. Notice that there is no g on the horizontal axis, this will be 0, half t square, so everything here will be 0. So r is going to be only equals to ut. And remember that the time we are talking about here is the time to move from this point to this point. That is the time to get here and then come down here. The time to move up to here, then come down here. So that is t, that is time of flight. That is why I use this. So we've not derived time of flight. When we derive time of flight, we'll come back and put it here. So, but we know that the u we are talking about here, anything on the x-axis, this u can also, when an angle is not given, we use this like this. But once an angle is given, we remember that u on the x-axis, as I've written this to be v, it can also be ux for initial. So when we are talking about final, we use vx, v cos. But when we are talking about initial, we use u. So it can also be ux. So this is the sentence. Replace it with u, so it will now become u cos theta times t. So when we find our t, what t, total time of flight is, we'll get back. So we can now see that, clearly see that we are getting somewhere. So now for total time of flight, using what we've discovered, total time, let's call this vertical, we are continuing, call this vertical, call this horizontal. So you now notice that the total time of flight, which is t, is going to be simply on the vertical axis. Let's look at this. On the vertical axis, it will be the same thing as saying you move up, you come down. Notice that if this is s, as it's going this way, the displacement is increasing. See, it's just like I throw something up, it's having 20, as it's coming down the same measurements, it will have minus 20. So everything here will equals to 0. It's more like positive minus equals to 0. So that means that the total displacement s, s will be equals to 0. So for that reason, if I want to find total time of flight in something of this nature, I will consider this end and this end. So I will say s is equals to ut plus half gt square, half at square. That's normal equation of motion. Now from here, the s for total time of flight is going to be 0, because the displacement, this is for displacement from this end to this place, whatever I get here, once it comes here, this will cancel this out. It's just like if something goes up and comes down, the displacement is 0, because when it go up, come down, is 0. Whatever happened here has been cancelled by this. So this is going to be 0 equals to ut plus gt square over 2. If this thing, okay, at square over 2, we've not converted it to g yet. So if this times this, it will go up, the 2 will come down. Now, since it's gravity, total time taken we are talking about, we need to change a to g, because when it went up, it attained gravity, and when it came down, it still passed through gravity. It went up, gravity was experienced, it came down, gravity was also experienced. So this will now be equals to ut plus gt square over 2, then 0. Now we need to check something. When it went up, it disobeyed gravity, as it's going up, that is total time of flight. It went up, disobeyed gravity, then came down, obeying gravity. So you see that whatever effect it has going up is having it coming down. But what we normally consider is, for the fact that it went up at all, we take it that this will now be 0 equals to ut, at this point. So we take it that for the fact that it went up, this will be minus gt square over 2. That going up alone puts the g, see, going up comes first. So it puts the gravity in a place where it's disobeying gravity, and if you go up, you must come down. So for the fact that it went up, you replace it with minus. For gravity, you don't do it went up and it came down, it should cancel it. No, for gravity, once it's going up, the acceleration is negative. So this will cross equality sign, so that it becomes minus ut equals to minus gt square over 2. This will cancel this. And then notice that I have t here. This will take care of this, so that I have u equals to gt over 2. This can go here, this can go here. I have 2u equals to gt. Then divide both sides by g to make t subject of formula. I have g over g. This can cancel this. Maybe you know. So I now have t is equals to 2u over g. So anytime an angle is not given, or theta is not given, t, which is total time of flight, is simply 2u over g. But once an angle is given, you simply need to go and remember that this t is stuck, it went to vertical side and came down, so it's more of the vertical. So total time of flight, this is a motion that goes through y-axis to come down, so it will be on the y-axis. So you just do 2u, replace the u with sine theta, because that's what the component is on the y-axis, over g. So you need to know this t, this is how you get your total time of flight. So now that I've gotten it, if I want to find the range that I've gotten it, there's no total time of flight on the horizontal axis. You need to know that. So if I want to find range now, from what we've gotten, that if the body moves this way and is this way, that there is always an initial velocity. That initial velocity to launch out with, before coming down, covering this distance, that we should multiply it with the total time taken. So the u multiplied by time, so that is range. So notice that u in the horizontal axis is u cos theta, and t in the time of flight is simply 2u sine theta all over g. So if you times the two, you simply have that r is equals to this r. Remember, we changed it to s. We said it's s that changed to r, and we try to derive it. So if you remember what we did, here. So this is the one we are now replacing with 2u sine theta all over g. So you multiply. So when you multiply through, you're going to have that this is going to be the same thing as saying r is equals to u times u becomes u square. Cos theta, then you have cos theta and sine theta. Then you have to, that is 2 sine theta cos theta all over g. And we know that in the trigonometry, we normally give that the identity 2 sine theta cos theta is equals to sine 2 theta. And if I know that, it simply means that r can also be the same thing as saying u square sine 2 theta. I'm replacing everything about this all over g. So it doesn't mean that this is not a formula. This is also our formula, and this is also our formula. So we just replace this with what is equals to. That is why in most cases, when you carry this thing and you are solving certain things, like when calculate the velocity at the angle, when the maximum height equals to range, those kind of questions, you still need to take this back to this. So this is just to make it less bulky. So everything we've discovered from the time of flight down to this point is all under case 1. You use most of these equations, all these equations, like for range, maximum height, time to reach maximum height, and total time of flight. You use all this for case 1. And case 1 is simply the situation we have here. This one, when the body is projected at an angle and it comes down peacefully, projected at an angle theta, it comes down, projected from here. But in case 2, once you see that the body is projected at an angle, so you make use of h equals to u square sine square theta over 2g in case 1. You make use of r equals to u square sine 2 theta in case 1. You make use of t equals to u sine theta over g in case 1. That is for time to reach maximum height. You make use of t equals to 2u sine theta over g in case 1. In case 2, you don't do it like that. You change step. You change dancing foot. So notice that this one is when at a height is projected at an angle. What you need to be considering here is 2 things. You must be doing to find maximum height. You must do 2 things. So you must consider this height and this height. Then the time to do everything here. Then when you get this, see what I mean? For this to find the height, you must do h first to be equals to maximum height. That is, notice that what we have up here, like everything up here is looking like your normal case 1. Then it now has an extension. So you do time to reach maximum height, which is u square sine square theta all over 2g plus the given height, which is this height. So the given height, whatever they give you as this height, let's say 20, whatever you get here, add it to the given height. That becomes your total height, or your greatest height, total height. That is how to find height or maximum height in this case. So this is what you must do for case 2. Everything you are doing in case 2, you are doing it 2. Everything are double. Oh yeah. Now see, to find the time here, the total time in this case 2, whenever it is projected from a height at an angle, what you will do is time to reach the maximum height. Because notice that this question from this point to this point looks exactly like our normal case 1. So you do everything from here to here. To find the time, you do the total time. You do, first of all, that t, what your time to reach maximum height is, which is u sine theta over g. So it's more like you find t, then plus, you now say, let's say this is a, let's say this is b. You now find time to move from a to b. And to find this time from a to b, all you need to do is to remember that this thing is, everything here is at a height. Is it not true? Height, which is displacement. So use s equals to ut plus half gt square. And in this case, your s is going to be h equals to, and notice that if this is the height, that is, we are trying to find the time from a to b, if this is the height, if this body is going down to this point, as it's going down, whenever your body is going down the vertical axis, once a body is going down on the vertical axis, the u becomes 0. So this is vertical. So this is u. When something is, or you think of it as when something is thrown down, u is 0, initial velocity is 0, times this t, you see that everything here will die, or it will get out. This is 0, it will get out. Now, when it's going down, when a body is going down, gravity is obeyed. That is why I'm leaving this plus and not minus. So it's going to be half gt square, then my h. So remember, our goal is to make this t subject of the formula. We're trying to find the time from this end to this end. So what we will do is to simply say h will be equals to gt square over 2. Gt square over 2. Then this will come and times this. It now becomes 2h equals to gt square. I'm making this subject of the formula, divide both sides by g. This. So by the time you make t subject of the formula, you now have square root of 2h. Now have square root of 2h all over g. So to find the time in this case, what you need to do in this case now is to do that time to reach maximum height plus time to move from the greatest height to the ground. So which is now we've now gotten it to be 2 square root of 2h all over g. So once you add it up, once you add these two up, you get the time, the total time in the air. So I say that this is the time from greatest heights to the ground. So everything you're doing here is double. Now if they ask you the range in this case, remember we are trying to find height, range, time of maximum height, and then total time of flight, and we've gotten the total time of flight here. So the total time of flight is simply gotten by doing time to reach maximum height plus time from greatest height to the ground. Now to find the range, which is from this point of projection, this to where it hits the ground, to find the range, which is r, we'll simply make use of what range is. S equals to ut plus half g, and you know that once we are here, g has no business. So r, s here changes to r, which is ut, and the t here is the t for what we've gotten everything here to be. So it's simply going to be the same thing as saying r is going to be equals to whatever we are given as the initial velocity, or if since an angle is given, it will now be u cos theta, then times whatever we get as our value for this, which is let's say u cos theta times u sin theta over g plus root 2h all over g. So this is going to be how you find your range in this case. As we start solving questions, you will see the application. So now for when the body is projected, that is case 3. When the body is projected from a height but horizontally, in this case there will be no max height. The maximum height will simply be the height of what you're given. The height of the top or height of whatever you're given will simply be equals to the height given or stated. So if they tell you that this is 10 meter high and a body is placed horizontally, It becomes the height. Now if they ask you the t, that is the time of maybe time to reach maximum height, time to reach this height, you can see very well that it is only going to be obtainable because the time to reach, that is to move from, that is here, you're already here, you are not going up again, you're already here, you're not going up again, this is the height, so you're already here, you're not going up again. It's simply what you're going to be checking is time to reach the ground, so which is your t, nothing like time to reach maximum height here, so your t, and to get it is simply going to be gotten using our normal formula. I told you in class that this formula S equals to ut plus half gt square is very important, but you just need to be observant when it should be minus and when it should be plus. Notice that as it's coming down, whenever it's coming down, anything is coming down, the u is 0. It will have v, but the u will be 0, and the v will be in such a way that it's the g will be in such a way that since it's coming down, it's positive. So to find the total time now to do this is simply going to be gotten by doing S equals to ut plus half gt square. So if I know that, I will now have that this is going to be the same thing as saying, see what I mean? If this body is coming down here, notice that it has a height. If this body is coming down, it has this height. Let me put it h equals to, now this is going to be 0. And 0 times anything is getting out. Then this one will remain positive because the g here is coming down, is obeying gravity, so half gt square. And this is the same thing as saying gt square over 2. It will times this, so we now have that this is going to be the same thing as saying 2h equals to gt square. Then divide both sides by g to make t such as the formula. Divide g. This will get out. This 2 will get out. So that I now have t, making t subject of the formula. T will now be equals to square root of 2h all over g. So this is how to find the time, the total time, and this t is equals to this. This is the t. How to find the time to the time taken for the body, the projectile, to hit the ground. This is how you get it. So once you know this, it simply means that you're good to go. Now if they ask you for the range, so notice that there's nothing like time to reach maximum height in this case, but rather total time taken. Now if they ask you the range from this point to this point, remember that range is simply the total horizontal distance, and every projectile is launched with an initial velocity. There's always an initial velocity, and when it cuts down and start coming down, the velocity changes. So once it start coming down, you now have final velocity. That's what you're expecting, while the initial becomes 0. So in that case, if I have this, range will always be u times t. So in this case, notice that there is no angle given. I'm not giving any angle, so the range is going to simply be the u that I'm giving times the t that I've gotten here, which is simply root 2h over g. Very simple. So let's move to case 4. In case 4, I have when the body is projected vertically. They say a ball is thrown vertically upwards. If a ball is thrown vertically upwards, I can see that this particular ball has no direction. It has no business with horizontal direction. This is the ball. They play it up, it will come down. Play it up, it will come down. So for that reason, if they ask me to find the maximum height, all I will need to do is to simply say v square is equals to u square. Remember I told you always use this formula anytime they ask you for maximum height, plus 2as. Now see, for the fact that the ball is played up, at maximum height or anything thrown up, the v final velocity will be 0 equals to u square. Now plus is going up, shebi, at maximum height. Let's say they are asking you for maximum height, so this will become 2 minus g. As it's going up, it's going against gravity, then I'll have h. S here becomes h. So if I do it, this becomes minus 2g h u square equals to 0. And notice that if you cross equality sign, it becomes minus u square equals to minus 2g h. This can cancel this. So if I know that this becomes u square equals to 2g h, to make h subject of the formula, since they are asking me for maximum height, divide both sides by 2g. So this will simply become what you use to calculate your height. So h is equals to u square all over 2g. This is what you use to calculate your maximum height. If they tell you that maximum height is 1/4 or half of or whatever, just come and put it around here. Do cross multiply, you solve further. So this is for vertical axis. There's nothing like horizontal range in this kind of question. There's nothing like time to, okay, there's time to reach maximum height, because if you check it, if they ask me time to reach maximum height, all I will simply do is to say s will be equals to ut plus half at square. Okay, if I'm doing this is for time, total time taken. But if I do v equals to u plus at, which is now the same thing as saying at maximum height, this will be 0 equals to u minus gt. That means that this will become minus u equals to minus gt. This will cancel this, so that this will now become u over g is equals to t. This is the time to reach the maximum height. There is no angle given, so t will simply be u over g. Why I said this is the one you use for time to reach maximum height is because you are not considering time to reach maximum height. You are not considering the height given. If you consider the height given at any point, it means that you are taking it that you've gone up and you've come down, and that is for total time taken or time of flight. So time to reach the maximum heights, if you reach maximum heights and then as you've reached the maximum height, what you are considering is the velocity that took you there. But if you reached it and you come back, you've really covered the distance. So in this case, at the point where this is plus, this one is minus, so you can describe what happened. So in that case, when we are considering the h given, we'll talk about the total time taken equals to ut plus half at square. And see, when it's going up is plus, when it's coming down is minus, so this is going to be 0 equals to ut plus and remember, for the fact that it went up, this becomes minus gt square over 2. Let this cross equal to, because minus ut equals to minus gt square over 2. This will become cancel, so that I have 2u equals to gt. That is, these two will go and times this u, then gt, these two cancelled one thing, so that if I make t subject of the formula, I now have 2u over g is equals to t, and the t here is supposed to be capital T, but you know we are getting it from the equation. So this one is the time to reach max height. But if deriving all these things all the time is hard for you, all you just need to do is to memorize it. This thing is the same thing as saying 2u sine theta. Just go to normal time of flight that we have, which is 2u sine theta over g. Remove the sine theta. Once an angle is not given, you have 2u over g. That is the time of maximum height whenever angle is not given. While if they ask you time to reach maximum height, once you look and you see that that particular question does not have angle, just says u over g, because this u over g here is something as saying u sine theta over g. So remove the sine once an angle is not given. You have time to reach maximum height. All right, let's move to case 5. Case 5, which is the second to the last one. So for case 5, case 5, they say when this is placed horizontally, if a ball is placed horizontally, I play this ball to my friend. I play this ball to my friend. They ask me to find the maximum height. It's not possible. And they ask me to find the time to reach maximum height. It's not possible. Then they ask me total time taken. Total time taken is possible. So I will simply get it by doing S equals to UT plus half GAT square. Very important formula. Half AT square. If I know this, I will now ask myself, whatever your initial velocity I'm giving is for the horizontal axis. So if it's 50, it will be there. So let me just call it U. Then T will be there. Then since it's horizontal, there's nothing like, you know that this is going to be acceleration due to gravity plus half gt square. There's nothing like gravity around horizontal axis but friction. So S is simply equals to UT. And whenever we are dealing with horizontal axis, this S becomes R equals to UT. So if they ask me the time taken, that is to do anything I'm doing here, what I will simply do is to simply say, or let me leave this as S. I'll simply say the total distance taken, watch, divided by, making the subject of the formula, I have T is equals to S over U. That is displacement over velocity. Are you getting it? So that is what I will use to get my T. If they ask me to find the total distance or the total or the range, I'll simply use UT, which is the same thing as saying from this end to this end. That is the time taken to move from here to here times the initial velocity given. So that will be my displacement, which is also called R. So but if they ask me to find the time, I just use this as my subject formula. I make it so. But another way to get the time taken from this end to this end is to simply say, if I do V equals to U plus AT, I notice that there's nothing like G. This is set as U plus GT. V equals to U. So you see that this will get out. So V equals to U. So that is why I think this is wrong. We can't use this. That is why I said initially, oh, I forgot. Initially, there's nothing like time to reach maximum heights. And we always get time for maximum heights using this. So it's not possible. So that is how you go about this for case 2. They can also ask you under this case 2, like vertical component, or what is the velocity at the vertical component, which you are not going to check because there's no movement at the vertical component. But if they ask you like find the velocity of the resultant velocity, in this case the resultant velocity is simply going to be whatever velocity you are giving here. You work with whatever velocity you are giving here. But if it's stated that there's a final velocity or there's a change, you use it, but you don't consider the vertical axis when you are dealing with horizontal axis. So if I know that, I need to quickly touch this. If at a point they tell me to find the resultant velocity of any projectile, especially case 1 or case 2, all I need to do is to first of all find the velocity on the y-axis, then find the velocity on the x-axis. Now when I find the two velocities, let's say Vy, then let's say Vx, when I find the two velocities, the resultant velocity, let's say Vr, will simply be equals to, using Pythagoras, Vr square is equals to Vy square plus Vx square. And when I make V as subject of the formula, I'll simply have square root of Vy square plus Vx square. This is how you get the resultant velocity. And if they ask you the direction, all you need to do is to remember that tan theta. In fact, anytime you use Pythagoras, is on my video for vectors and scalars. Anytime you use Pythagoras, you always use tan theta to find direction. While anytime you use if you use cosine rule to find your resultant, you always use sine rule to find your direction. So tan theta will simply be equals to y over x, which is the same thing as saying sin theta over cos theta. So this is going to be the same thing as saying Vy all over Vx. So this is how you find your direction. So let's go to the last case, case 2. Case 6. So in this case 6, if they tell you a body moves this way and then lands on this body, and they tell you to find the maximum height, all you need to do in this case is to simply apply case 2. Apply your case 2. So there's an angle, find the maximum height, which is, notice that everything here is looking like the normal case 1. So find the maximum height, u square sine square theta all over 2g. Then you found this. Then add it to what you have here. So plus given height. If you add it to the given height, you get your total or your greatest height. Now once you get it, once you get your greatest height, the next thing now is to get your time, your total time. And your total time, let's say I call this part A, B, C. Your total time is simply going to be, watch, it started here and it reached here. So time to reach maximum height, that is from A to B. So I'll simply do u square, time to reach 2u, what am I doing? Time to reach maximum height, u sine theta all over g. This is what happens when you're thinking many things at the same time. So u sine theta all over g, that is from A to B. That is A to B. Time from A to B. Time from A to B. You get it? Then plus. You now get the time. The time from B to C. The time from B to C. And this time for B to C. This time for B to C. You will get it by considering first of all the height from B to C. So if, for example, what I'm giving here is 100 meter. If I'm giving 100 meter here, I'll simply say what is the total time from this end to this end. So I'll simply make use of my hedge. First of all, I'll make use of my hedge. That is hedge equals to ut plus half gt square. Notice that as it's landing, as it's going down, this u, when something is coming down, u will be 0. So everything here will be cancelled out. So hedge will be equals to, as it's coming down, gravity is being obeyed. Hedge will be equals to gt square over 2. So this will now become 2 hedge equals to gt square. Divide both sides by g. So t will be equals to root 2h over g. So this case 6 is more like the case 2. It's just that most people mistake it. Everything you're doing it 2. Now what is the height? What is the height you're going to use from this end to this end? What is the height you're going to use from this end to this end? Height that you're going to use from this end to this end is simply, notice, the height that you got from doing u square sine square theta all over g. That is the height you place inside here. The height you place inside here is going to be the height gotten from doing Notice, see, watch so that we don't confuse ourselves. I did from this end to this end to get to the maximum height. Then when I did from this end to this end to get the maximum height, I now did plus giving heights. Okay, this end to this end, yes. And notice that if I have this end to this end, then I should have from this point to this point, which is still inside here. I think there's a mistake somewhere. This from this end to this end is still inside this, shebi, and even this is still, yes. So in this case, that means that for us, first of all, the greatest height here, if you check it, the greatest height here, if we do from this point to this point, it covers the whole height. So for this case 6 is not the same. Case 6 is simply using maximum height, that is u square sine square theta over 2g. There's nothing like plus giving height. We don't look at giving height because it went past the given height. So what we do is just using our maximum height, u square sine square theta, we get the total height. And when we get this total height, we don't do anything like giving height. So for us to now get from this point to this point, what we need to do is to subtract this particular height. We subtract this height. So that means when we subtract the height we are going to use is simply, the height we are going to use to do this one, from this one to this one, is simply what we got from maximum height minus given height. I'm very correct. Yes, don't get confused. So to get the total height here is simply to do from this end to this end. Because this is inside here. So that is the maximum height you get. If you get it, don't add anything. Then once you get it, to get now the total time taken, you do time to reach this maximum height, which is u sine theta over g, plus, notice that it did not land again to complete it, so plus the point where it landed here. So you subtract this one out, which is the given height. You do maximum height minus the given height. Whatever height you get, whatever measurements you get for the height, that is what you put here. So this is the sentence saying that the t that I will have here is simply root 2 of the h minus given height. So all over g. That is what you use. So by the time you get this, add it to what you have here. So that total time now will be u sine theta over g. U sine theta over g, come here. Is too much over here. So u sine theta over g plus root 2h minus, you know that you're timesing. That is the answer you got for h minus given height all over g. That is the answer. Thank you. Subscribe.